Lab for Group 5A.
I'm Cameron.
I'm Katie.
I'm Tony.
So for our experiment for dropping the ball, we chose to change the angles that we dropped the ball at, and we dropped the ball down a whiteboard as a ramp, and once the ball leaves the ramp, it will be dropping 1 meter every single time, and our question was how much kinetic energy is lost after each bounce at these angles, and what angle gives the least amount of kinetic energy lost. For our first trial, we just dropped it regularly at 90 degrees, and here is a screenshot of our tracker screen for this trial. And as you can see, we just have the meter stick and then it calibrated, and then our points for the mass, which is our bouncy ball. And for our graphs, we focused on velocity, and that was it for our experiment, but we put position in just to give an example of the motion of the ball. But the collision of the ball is at 2.5 seconds with the ground, and this is our area of interest, specifically before and after. So we found the initial velocity and final velocity of the ball for this trial to find how much KE is lost. So we found those two values, and at before the ball collided and after the ball collided with the ground, and we used the KE equation, 1/2 mv squared, and plugged that in to find the initial KE and final KE. And then we used KE initial minus KE final over KE initial to find the percent lost. And we found that it was 18.7% KE lost after the collision.
So for our second trial, we did this one at 39.5 degrees. As you can see from the screenshot from our tracker video analysis, we determined this angle after the course of the experiment using the protractor tool in the tracker software. So it shows like a pretty nice demonstration of like how the ball moved in this experiment. Looking at this, you can see from our velocity graph that the collision occurred right around 3.4 to like just over 3.4 seconds, and that's kind of our area of interest of just before the collision and just after the collision. So from our results, we used the tracker algorithm to find initial and final velocities, and then used the KE equation of 1/2 mv squared to find kinetic energy initial and final. And then using the equation KEI minus KEF over KEI, we found that this scenario had a 33.6% loss in kinetic energy. In our trial 3, we had it set up to 29.6 degrees. Again, this measurement was quantified using the protractor in the tracker software. In this particular scenario, you can see the collision occurred at around 3.8 to 3.9 seconds, so that's our area of interest. And then our results is we use the tracker to find our initial velocity and all of our variables, and our percent kinetic energy loss was 52.3%, so a pretty big increase.
In trial 4, basically we did the same thing. We just lowered the degrees to about 22.4 degrees using protractor to angle it. As you can see in our velocity graphs, the first collision occurred at about 3.0 seconds, and you can see afterwards what we got from that was we got the initial velocity as well as the final velocity doing the same KEI minus KEF equation over KEI, and we found that our KE lost was about 50.75%. And this leads us to a conclusion that our hypothesis was actually correct, that the higher the angle, there'd be less KE loss.